In this example, we're going to be decoding a message that has been given to us. So the following message was coded using the matrix A. So the matrix A is a 3x3 matrix. First row, 1, 1, 1. Second row, 1, 3, 5. And the third row, 1, 5, 7. And here is a nice long string of digits that has absolutely no meaning to me as of yet. What we're going to do is decode this message. So the idea is, if you have a coding matrix A, we'll define M to be our message matrix, and we'll say C is our coded message matrix. So the first thing we're going to need to do is take these, this string here, and turn it into a coded message matrix. The idea was, when we took our message matrix and multiplied on the right by A, that would give us a coded message. Now, using the same sort of logic, if we're interested in finding the message matrix, we would multiply the coded message on the right by A inverse. Now, since A is a 3x3, that lets us know that A inverse will be a 3x3 as well. Now, in order for the matrix multiplication to even make sense, that means that the number of columns of C is going to have to be 3. The number of rows we don't necessarily know at this point. But the important thing is, if we know the number of columns, we'll be okay. So don't necessarily know how tall this is going to be, but we do know that there should be 3 columns here. So I'm going to start loading the coded message into the coded message matrix. So this will be 27, 87, 129 for the first row. Then 36, 116, 156 for the second row. 13, 23, 33 for the third row. 33, 99, and 133 for the fourth row. Then 23, 59, 95 for the fifth row. 42, 106, 160 for the sixth row, and finally a trio of 18s for our seventh row. So overall we wound up with a 7x3 matrix. Now, rather than actually doing this thing, what I'm going to do is grab the calculator and get the calculator to help me out a little bit here. So what we wind up with will be our message matrix. Now, here's where the calculator is going to come in handy, because we can use this to not necessarily have to calculate the inverse matrix, nor perform the matrix multiplication ourselves. So first thing we'll do is we'll edit a 3x3, and we'll use this as the coding matrix. That was 1, 1, 1, 1, 3, 5, and 1, 5, 7. See, that's looking good. We'll quit out of here, and then we'll re-enter the matrix menu to edit matrix B. Matrix B will be our coded message matrix, so we'll need a 7x3 matrix. That'll be 27, 87, 129 for the first row. 36, 116, 156 for the second row. 13, 23, 33 for the third row. 33, 99, 133 for the fourth row. 23, 59, 95 for the fifth row. 42, 106, 160 for the sixth row, and 18, 18, 18 for the last row. So the idea is I want to take this and I want to multiply it on the right by A inverse. So I'm going to quit out of that menu, re-enter the matrix menu, select B, and then we'll multiply that on the right by A inverse. So B times A inverse should give us the decoded message matrix. So we'll put this right over here, and just in case it's a little too lit up and you can't see it particularly well, this says 6, 12, 9, 16, 0, 20, 8, 5, 0, 16, 1, 16, 5, 18, 0, 15, 22, 5, 18, 0, 0. All right. Next we get to translate from numerical code back into letters. 6, that is F. 12 is L. 9 is I. 16 is P. That's a space, so flip. 20 is T. 8 is H. 5 is E. Flip the 0 space. 16 P. 1 is A. P. 5 is E. 18 is R. Space. 15 is O. 22 is V. 5 is E. And 18 is R. Flip the paper over. Okie dokie. Hooray, you did it! Woo! We're awesome.